This lesson is over central angles and arcs. The objective, students will be able to find the measurements of arcs and the lengths of arcs by using the central angle. So obviously the first vocab we're going to talk about, a central angle is an angle whose vertex is the center of the circle. So we have the central angle APC. That's this angle right here. So whatever that angle measurement is what we're talking about. But we also define this arc by that same angle measurement. So if that angle was 120, this arc we'd call 120 degrees. We'll get into that in a second. So the other thing is how to label these and what all these mean. So BC is a minor arc. So BC is right here. Guess I should use a different color right here. This is the angle, the central angle that goes with that arc. They use 2 letters for a minor arc. If they do a major arc is where it goes, it's more than 180 degrees. It's more than half of the circle. So MAC is MAC. Now the reason we have to distinguish between 3 letters and 2 letters is because if I tell you, if I just say find the arc BC, like over here, how do you know that it's the arc right here? Or is it the arc that goes all the way around this way? And so that's why with a major arc, we use 3 letters. So the 2 arcs that I just drew in here, this one would be BC, just like we talked about over here. But the one that goes all the way around this way, we would have to call either BAC or BMC or something where you're using 3 letters. And so that's how you know the difference. If they're using 3 letters, that means they're going all the way around. So it's more than 180 degrees. It's more than half the circle. If they are using the diameter exactly 180 degrees, then you could either use 2 letters or 3 letters. It doesn't make any difference. But again, that's the diameter. 180 degrees is the central angle. This angle here is 180, and it's half of the circle. So a couple of the vocab things. The measures of a minor arc is equal to the measure of its corresponding central angle. And so that's what I was talking about earlier, where this central angle right here is 50 degrees. So the arc NP is measured as 50 degrees. The measure of a major arc is the measure of the related minor arc subtracted from 360. So now let's talk about this. So I have my minor arc is NP, we said that's 50, and then they want you to find the arc, the major arc, NAP, so the one that goes the other way around. Now there's 2 ways to think about it. Just like they said, it's the minor arc subtracted by 360, so you can just take 360 minus 50. So that's 310, so that's the answer. But it kind of helps with this one. Why is it? Why are we doing 360? Instead of just memorizing that, why are we using 360? Well, the reason we're using 360 is because 360 degrees is the full circle. If you go 1 full revolution, that's 360 degrees. And you guys have heard that all when you're talking about your skateboarding or snowboarding or gymnastics and stuff. When they do a full twist, that's 360 degrees. So if the full circle is 360 degrees, and we've already used 50 of it for this one, that means this other one is 310. So when they give you this kind of formula where you take the minor arc subtracted by 360, you can remember that, but I think it's just as easy to realize the concept where the full circle is 360 degrees. So if this is 50 degrees, then the other part of it has to be 360 minus 50. Then last but not least, the measure of a semicircle, you guys probably should know this, is 180 degrees. And that's this, A and P, they say. And again, it's 180 degrees because it's just half the circle. So the diameter, that central angle would be 180 degrees here, or over here, I guess would be more technical. Now, the next thing we're going to do is we're going to talk about the arc addition postulate. Now, this one is not specifically in your notes. This one is, and we'll get to this in a second. But I wanted to put this one in kind of to warm you up because, first off, we have done the segment addition postulate, and we have done the angle addition postulate. Whoop. So the segment addition postulate is if we have this segment right here is 3, and this segment right here is 5, then the whole thing from this beginning to this end has to be 8. We just add those together. Same thing with the angles. If we have one angle right here that is 20 degrees, and we have one angle right here that is 70 degrees, the whole angle from here to here is 90 degrees. You just add those together. That's the angle addition postulate, segment addition postulate. So the arc addition postulate is very similar. So if I wanted to know what the arc, erase this quick. If I wanted to know what the measurement of the arc BCD, if I wanted to know what that was, this whole thing, BCD, all you have to do is say, well, this is the angle, that's the central angle. So that's made up of 50 and 70, so it's just 50 plus 70. Shouldn't be too bad. Now, the other thing is that you can also use this kind of backwards to use subtraction to find some of these answers. So, for instance, if I want to know, they didn't label what this arc was, so if I said, what's the angle right here? Well, I know this is 90 degrees right here. They label that. Well, if this is 50 and the whole thing is 90, then 90 minus 50 is going to be this angle. So that arc BA, measurement of BA, is 40 degrees. And you could also say we know that because the angle BOA is 40 degrees. Could have done the same thing up here with the angle BOD. So that's the angle addition postulate, and I think it's a little bit easier with this one where you can see these two, we add those together. But then if you're looking at this one, these two we subtracted. We knew the whole thing was 90. This part, first part's 50, so that means that's 40 for this other. So let's look at these. So again, this is kind of how they describe it. You can add the measurements of adjacent arcs just as you can add the measures of adjacent segments or angles. So we are looking for BN and BP. So for me, first off, I think honestly the easiest way to do it, anytime I see a problem like this, is I just find all the angles that we don't know. So this is a diameter, so it makes it a semicircle. So I know the whole thing is 180 degrees. So I know this one's 180 degrees, but I also know this one, this whole thing is. Well, if that whole thing is 180 degrees and we have a 30 and a 50, that means this one has to be 100 degrees. Because the whole thing is 180. I'm subtracting the 30 and subtracting the 50. That ends up leaving me with 180. Now, again, you can double check by adding. 30 plus 100 plus 50 has to add up to be 180. So now that we know that that's 100, and again, I haven't even looked at my questions yet. Now that I know we have 30, 100, 50, and 180, now it's going to help me a lot by answering these questions. It's going to go a lot quicker. So BN is the screen one right here. That is 100 degrees. That's what we just found. Now, the next one you have to be careful. BP is this one. BP goes from here all the way to this one. Well, we know we have 100, we have 50, so that's 150. But again, I think it helps, and we actually didn't even need to know this 80 over here, or sorry, this 180. But again, if you can look at your picture and get all those angles, it's going to make the rest of it go a lot smoother. The reason I say that is because you'll have problems that look like this, where we have to find all these angles. They list BC, BD, ABC, AB, and the angle BOA. Now remember, the angle BOA is just another angle. So again, before we find all that, I think it helps by realizing we have 32 here. This one, so sometimes they label the angle down here, sometimes they label it up here. I guess technically this 32, they're labeling the angle, the 58, they're labeling the arc. I like to put it all down in the middle. And so if you look CA, and sometimes they specify, but CA has to be a diameter. So again, that's 180. So if this part's 58, then you take 180 minus 58 is 122. Now you could do the same thing with that the diameter, and you could say we have 32, and that whole thing has to be 180. Or you could realize that the full circle is 360, so you could take 360 minus 32 minus 58 minus 122. That should give you the same answer. So let's do it that way. 360 minus 32 minus 58 minus 122. That gives me 148. Oops, 148. And again, that should be the same thing, and that took a little longer, but that should be the same thing as this part where you say the whole thing is 180. So 180 minus 32 should be 148. Now again, if you want to double check before you do all this work, add all those together. I caught a mistake doing this the other day. 32 plus 58 plus 122 plus 148 is 360. So that's a good way to double check. Now again, I didn't even look at my A, B, C, D, and E yet. So I set those up. My BC, arc BC is this one, and that's 32. Now that I have it set up, it's real easy. Arc BD is 32 plus 58. 32 plus 58 is 90. I guess I should add this to your notes just in case that helps. ABC, so this one's going to be bigger than 180 because it's a major arc since there's 3 letters. So ABC, I guess it's the exact same as 180, which is fine. You can do 2 or 3 with that one. AB is this one right here. AB is 148. And this last one, angle BOA, well, BOA is this angle right here. That's the same angle we just talked about, 148. So even if they ask for the angle, don't make it harder than it is. Just make sure that's what you're looking for. Make sure you're looking at the right angle. Remember, when you're looking at an angle, that vertex always is that middle number or middle letter. So go ahead, do these on your own. They tell you M, R, and N, M, Q, and N, R are diameters, so that will help. Go ahead, do this one on your own. So pause it, do this on your own, and then hit play so you can see the answers to this. So in my opinion, again, I'm going to go through and I'm going to find all the angles that we don't know. So they say NR is a diameter, this one right here. So again, we have 180 degrees, 63 is here, and 82 is here. So if I do 180 minus 63 minus 82, 180 minus 63 minus 82 gives me 35. Now again, if you want to double check, it's not a bad idea. Now add all 3 of those together, make sure you get 180. So 82 plus 35 plus 63 is 180, so we're good. Now the other one they give you is MQ is the diameter. So again, now we have the same scenario with 180, and we have 82 and 35. So 180 minus 82 minus 35. 180 minus 32 minus, sorry, minus 82, that was close. Minus 82 minus 35 is 63. Oh, which is interesting. So that is 63. You could have also told by vertical angles. Remember, the 2 angles that are made up of the same 2 lines, they're right across from each other, have to be congruent. So if you remember that, you can use it, or you can find it just like I did. It's a little quicker if you recognize that it's a vertical angle. But if you don't remember that at all, you can find it this way. Now make sure you realize that this angle, the other angle we have, this is not 82, because it's not made up of the same 2 lines that makes up this 82. This new angle is made up of the green and blue line. The old 80, the other 82 is blue and this red line that I just made. So again, we have 180 degrees. So this one is 180 minus 63 is 117. And again, when I'm done, if I were you, I'd add all those together and make sure you get 360. So we have 63 plus 117 plus 63 plus 35 plus 82 does get you 360. So that's a good thing to do before you answer these questions. So now we know. Now, if they ever put this M in front, they're saying the measurement. Technically, I could have put the M in front of all these, but you don't really need to. So the measurement of MN is 63. The measurement of NQR is 180 degrees. If you want to add those together, you can, but it's a semicircle. It's a radius, or a diameter. QR, now we're talking about this one right here. QR is 63. Technically, I should be putting degrees, but you don't need that. QMR, so QMR, again, you can either add 35, 82, 63, and 117 together, or if it's the whole circle except for the 63, you could take 360 minus 63. It doesn't make any difference. So you could either do 360 minus 63, or 35 plus 82 plus 63 plus 117. Doesn't make any difference. 360 minus 63 is quicker, but I think that takes a little bit more. I think you have to think a little bit harder on that one. The other one takes a little bit longer, but I think it's a little bit easier mentally. And then PRN. PRN. Let me erase some of this. Whoops. Get that out of here. So PRN is PRN. Again, it's the whole circle except for this 82, so you can either take 360 minus 82, 360 minus 82 is 278, or you could add all those together like I said. We have 35 plus 63 plus 117 plus 63 should give you the exact same answer. If you want to do it both ways to double check, definitely not a bad idea. So far we've talked about the measure of these. The measure of the arc is the degrees. So the measure of an arc is in degrees equal to the corresponding angle, while the arc length is going to be in inches or centimeters or meters or something like that, and it's a fraction of the circle's circumference. So we have this picture here. I was going to say, I think they say this. So the measurement versus the length, and this is not in your notes. When you're looking at the central angle, we learned the arc's measure is in degrees. We'll see that the arcs have a length as well. So what's the arc measure of arc AB? Well, again, with arc AB, the measure is 100 degrees. What is the length of AB? Well, again, you kind of have to wrap your ruler around this one. This looks like it's about 6 centimeters. Now, before I go on, I know this is kind of confusing, but please remember, the questions you have on this will be multiple choice. The questions you have will be multiple choice, and they aren't going to, like, they're not going to put, if I said, what's the arc length of AB, I wouldn't put both of these answers. It'd be one or the other. So as long as you understand how to find both of them, you're not going to have any tricky ones where you have to pick one or the other. It's definitely going to be not in one question. So again, if I just ask you what length AB was for multiple choice, I wouldn't have 100 degrees and 6 centimeters be two options where you have to know, oh, well, the measure is the angle and the length is the 6 centimeters. You won't have to do that. So it's a little bit confusing, but before we get too bogged down by it, please realize that you're not going to have to distinguish between those two. So last but not least, remember the circumference. This isn't in your notes. To find the circumference, that is wrong. Pi r squared is the area, not the circumference. The circumference is 2 times pi times the radius. Sorry about that. Have to check your notes on that. So your circumference is 2 times pi times the radius. That's the whole length. It goes from here all the way around. So if I wanted to know what the circumference of this one was, the diameter is 20 inches. So the radius is 10. So the circumference is 2 times pi times the radius. So if you put that in your calculator, 2 times pi times the radius is 62.83. So that's the whole length all the way around is the whole circumference. So if the whole circumference is 62.83, let me write this a little bit cleaner and bigger, 62.83, the whole thing. What if it was half the circle? What if it just went from here to here? What would your length be? Well, you guys all knew if it was half the circle, you'd say, oh, you take this and you would divide that by 2. So 62.83 divided by 2 is 31.42. What if it was a quarter of your circle? So what if instead of half the circle, I just wanted to find the arc length of this right here, just a quarter of your circle? Well, if it's a quarter of your circle, it's 25% of your circle. There's 2 ways to do it. You could take this whole thing and divide it by 4 because it's 1/4. There's 1, 2, 3, 4 of those. So you could take 62.83 divided by 4. 62.83 divided by 4 15.71. Or the other way to do it is if you just took that, if it's 25%, we can make that into a decimal, 0.25, and then we can multiply those two together. That's the same thing. So 62.83 multiplied by 0.25 gives you the exact same number. Now the reason I say that is because now when I ask for 20% of your circle, some of you guys maybe know that you actually divide by 5, but do yourself a favor and make it easier. 20% of my circle is just multiplying by 0.20. So 62.83 multiplied by 0.20 is 12.57. That's what we're doing. Basically, we are going to be finding different lengths of the arc. And so it's kind of what we did with this one. So let's get into some of these problems now. I think I'm going to skip over that. Yeah, this is kind of what I just talked about. So the formula that you're going to use, the measure arc, blah, 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 the arc length is a fraction of circumference. The formula is the length of an arc is whatever your central angle is, or whatever they measure the arc in degrees, divided by 360. And then you're multiplying that by 2 times pi times the radius, because that's that formula for your circumference. So the arc divided by 360. Again, if we go back to the original we were just doing, the whole thing is 360 degrees. So if I want half of that circle, half of the circle is 180 degrees. So if you take 180 degrees divided by 360, that's going to get you 1/2, and that's what you're going to multiply by your original circumference. Same thing, this 25%, this is 90 degrees right here. So if it's 90 degrees, the whole thing is 360, so divide that to get a fraction, or to get your percentage, if you wanted to look at it that way. 90 divided by 360 ends up being 0.25. That's where we got that 25, or the 25%. So that's what that formula essentially is saying. You are going to take your degrees, your central angle, or your measurement in your degrees, divide that by 360. That's going to get you what percentage of the circle that is, and then you're going to multiply that by the circumference, 2 pi r. Now, if that doesn't make sense, if that doesn't help, if you just follow that formula, it'll work every time. So find the length of the following arcs. So I want to find the length xy. The diameter is 16 degrees, so make sure you realize the radius is 8. So they say that this is 90 degrees. They indicate that right here. So it's 90 degrees out of, and it's, the denominator is always going to be 360. I always put that in parentheses, multiplied by 2 pi times the radius is 8. Now, if you use parentheses like this, if you want to put it all in your calculator, that's fine. I like to do it in 2 separate parts. So 90 divided by 360. If you need to round to 2 decimal places, you can, but that's 0.25. And then 2 times pi times 8. That one you will have to round to 2 decimal places, 50.27. And now I multiply those together. Now again, you could do it in one step if you use parentheses. It just gets a little bit confusing if you do it that way sometimes. 0.25 times 50.27 ends up being 12.57. So again, this 0.25 means this arc is 25% of the whole circle. And then we multiplied it by the whole circumference would be 50.27. So we took 25% of the 50.27. So this one, xmy, so we're doing the opposite way. So my radius is 15 centimeters, and again, my central angle is 240, or my arc, measured as an angle, is 240, multiplied by 2 pi times 15. 240 divided by 360 is 0.666 repeating, so I'm going to make that 0.67. If you want to be more accurate, you can make it 0.667 or go more decimals, but we'll just round it to. That multiplied by 2 times pi times 15 is 94.25. So multiply those together, you end up getting 63.15 roughly. And technically, I should be labeling that centimeters. What was the last one? The last one was inches. So again, we took It is 0.67% of the whole circle, 2/3 actually, but 0.67%, and the whole circle is 94.25. So 67% of 94 is at 63.15. And again, really it's just plugging these numbers in. This is give you the diameter, so the radius is 12. We want AB, they say this one is 60. Well, if that's 60, this one has to be 120 because it makes up this diameter. So same thing, 120 divided by 360, multiplied by 2 times pi times the radius is 12. So 120 divided by 360 is 0.33, multiplied by 2 times pi times 12, 75.40. 0.33 times 75.40 is 24.882. I guess I rounded 2 decimal places. Feet. So again, go ahead and do this one on your own real quick, and then we will then hit play so you can watch the answer. Again, this one's 100 degrees, so it's 100 over 360. How are we starting? Multiplied by 2 times pi times the radius is 18. So 100 divided by 360 is 0.28, so 28% of the whole circle. 2 times pi times 18, I guess I can put that in my calculator. 2 times pi times 18 is 113.10. Multiply those together, you end up getting 31.67 inches. And again, that is the length. If you were to take this green length right here and take it out and make it straight and measure it with a ruler, that's how long that would be. Because again, the whole thing is 113.10. So then we're just taking 28% of it, because 100 over 360 is 28%. 28% of it is that 31.67. Last but not least, really quickly, we have a couple more vocab words. A chord is a segment that has endpoints on the circle. Oh, so it is a chord over there. I couldn't see it on my screen. A chord that passes through the center is a diameter. So again, this is a chord. The endpoints are on the circle. If you have a radius, is not a chord because this endpoint is not on the circle. So again, if a chord goes through the center, it is the diameter. What's the longest chord a circle could have is that diameter. If you look at a circle, that's the widest it could be. If I start moving this up, it gets smaller and smaller and smaller. If I start moving it down, we get smaller, 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 smaller. So the longest chord you could have is the diameter, assuming you draw a perfect circle, which this is not. Oops. Now, really quickly, just one little extra thing, congruent arcs. In the same or congruent circles, if 2 arcs are congruent, then their chords are congruent. So if you look at this, since DC and AB are marked as congruent. Oh, sorry. Let me go backwards the other way. Since arc DC and arc AB are both 75 degrees, that means the chords have to be congruent. This chord has to be congruent to this chord. Now, it's also the same thing the other way around. If 2 chords are congruent, then their arcs are congruent. So now the same thing. If I said DC and AB are congruent, so I gave you those marks, then that means the arcs DC and AB are congruent. So if you have any questions, make sure you're emailing me. Thanks for watching that.